Good afternoon. In the last lecture, we have discussed direction ratios and direction cosines. In the continuation of the same topic, the direction ratios and direction cosines, so by definition, everybody should be clear. Direction cosines of a line means if a line makes angle alpha, beta, gamma with coordinate x, y, z axis, then cos alpha, cos beta, cos gamma are called direction cosines, and these are also denoted by LMN. Similarly, any three numbers which are proportional to direction cosines of a line are called direction ratios. So there may be infinite set of direction ratios of a straight line, but direction cosines are fixed. Since there is a standard relation between them, L square plus M square plus N square equal to 1. Okay. So first is continuation of the previous lecture. Direction ratios of joining of 2 points. Direction ratios of joining of 2 points. Joining of 2 points. Suppose points are xp, x1, y1, z1 and q, x2, y2, z2. Okay. So direction ratios of joining of these points are x2 minus x1, y2 minus y1, z2 minus z1. Very simple. This is the direction ratios of joining of 2 points, x2 minus x1, y2 minus y1, z2 minus z1. Direction ratios are known, then we can also find direction cosine. That is, these are taking as ABC. So you can also find element. Okay. For example, the direction ratios and direction cosines of joining of points 1, 2, 3 and minus 2, 4, minus 5. Okay, joining of 2 points. So we take it is x1, y1, z1, x2, y2, z2. So x2 minus x1, that is minus 3, that therefore dr's direction ratios are minus 3 and 4 minus 2, that is 2 and minus 5 minus 8. These are dr's by formula x2 minus x1, y2 minus y1, z2 minus z1. And DRs are known, then you can also find DCs. That is, these are taking ABC. So, and DCs are, that is, direction cosines are, we know that L equal to A upon under root A square plus B square plus C square. This is minus 3 upon under root 9 plus 4 plus 64. Okay, that is minus 3 upon and 68, that is 77 under. Okay, and similarly M equal to B upon 2 upon under root 77 and N equal to C upon minus 8 upon under root 77. Okay, so these are direction cosines of the joining of 2 points. So it is very clear. Next thing, which is very important in vector algebra, if any general vector A is given as A1i, A2j, A3k, this is unit vector, and vector A is any given. So the coefficient of I, j, k are direction ratios of this vector. That is, its dr's direction ratios are A1, A2, A3. So learn this thing, that if any vector is given, then coefficient of I, j, k are its direction ratios. And if direction ratios are given, you can also find direction cosines of this. And next thing is, which is important, projection of joining of two points, for example, suppose we take as p x1 y1 z1 and q x2 y2 z2 on a line AB. Okay, so projection, this is clear, that is shadow of the joining. For example, if joining of PQR, a line, this is PQ joining, and this is a line AB, suppose, and projection of this is draw perpendicular from P and Q on AB. These are respectively PM and QN. So MN is the projection of, this is equal to by figure MN. And this is the joining of point x1 y1 z1, x2 y2 z2. And suppose disease of line AB are L, M, N, then this projection will be x2 minus x1 into L in plus y2 minus y1 equal to M plus z2 minus z1 equal to N. This is the formula of projection. Projection of joining of PQ, which is geometrically equal to Mn, that is shadow of PQ on line AB, which is Mn, and equal to x2 minus x1 L plus y2 minus y1 M plus z2 minus z1, and you can find projection of joining of 2 points on a given line. Okay, then till today in our study, it is clear that direction ratios and direction cosines are very important thing to understand 3D. This is very important topic. So further, as in case of 2D, the angle between two lines can be found in terms of slope. Similarly, in 3D, the angles between two lines can be found in terms of dCs or dRs. Okay, so the next formula our will be direct angles between two lines. Two straight lines. Suppose there is two lines and angle is theta between them. So first, in terms of dCs, let dCs of the lines L1 M1 M1 and L2 M2 M2. So angle is theta, then cos theta equal to L1 L2 plus M1 M2 plus N1 N2. This is the formula of angle between two lines. And in particular, if lines are perpendicular, that is theta is 90. Theta is 90, cos 90 is 0, so its condition will be L1 L2 plus M1 M2 plus N1 N2 equal to 0. It is called condition of perpendicularity. Okay, if lines are parallel, it means theta is 0. So now we find in terms of sine theta, after reducing sine theta by Lagrange's identity, and the condition becomes L1 upon L2, condition of parallelism, L1 upon L2 M1 upon M2 equal to N1 upon N2. Okay, this is the condition of parallelism. If two lines are parallel, this is the condition of perpendicularity. Okay, this is condition, and we read in terms of direction cosines. If direction ratios are given, and we can use directly direction ratios to find angle between two given lines. Yeah. So for which the in terms of drs, yeah. Suppose angle between two lines is theta and drs are a1, b1, c1, and other line these are a2, b2, c2. So angle between them cos theta a1, a2 plus b1, b2 plus c1, c2 upon under root a1 square plus b1 square plus c1 square into under root a2 square plus b2 square plus c2 square. And in particular, if lines are perpendicular, that is condition of perpendicularity is same as in case of disease, that is then a1 a2 plus b1 b2 plus c1 c2 equal to 0. And if lines are parallel, okay, then the condition of parallelism is same as in terms of disease. A1 A2 equal to B1 B2 equal to C1 C2. This is condition of collinearity and also parallelism. This is if lines. Yeah. Okay. So this is very important formula for further study. The angle between two lines in terms of disease and drs both. So either of them be given, we can find angle between the given lines. Okay, and further our lecture will be based on plane. This is the basic about 3D. First 3D geometry, elementary formula and direction ratios, direction cosines. This part is completed, and next lecture will be based on plane. So we advise that you revise from textbook the equations of the different equation of the planes in 3D. Okay.